All right, my friends. So for 77, it says let f and g be the functions given by f of x equaling e to the x and g of x equaling x to the fourth. They want to know on what intervals is the rate of change of f greater than the rate of change of g. So basically they want to know when is f prime of x greater than g prime of x. All right, the derivatives are easy enough to do. So f prime would be e to the x and g prime would be 4x cubed. And so we're just basically looking for, if you graph e to the x, when is it higher than the graph of 4x cubed? Now, a quick little concept picture of this. So, like here's e to the x, and it's like pretty steep. Let's see, can I even draw this? And then at 4x cubed looks something like this, and then it like, how does this work? So 4x cubed passes up e to the x at first, but then e to the x, let's see, 4x cubed isn't really that steep. Basically like that, and then e to the x kind of comes around and like crosses it again. So that's the story. I will say that I tried graphing like e to the x as one function and 4x cubed as the other, and I was just looking for like, when is one, when is e to the x higher? I had a hard time seeing both intersections at the same time, and so I think there's a better way to go about this as opposed to just graphing them and looking for which one's higher. So I think that you'll have an easier time like knowing, like the tricky part with this method was the window, like what window would make sense so you could see both the intersections. So what I would recommend in this case is actually just subtracting one function over and getting 0 on one side. So like e to the x minus 4x cubed, and you'd be looking for when is that greater than 0. And so what you can do is just graph this function and look for when it's above the x-axis, and then that would be the places for when f prime was greater than g prime. So, and why is that better? So here y1 was f prime and y2 was g prime, and then I just did this for some dumb reason anyway. So I'm gonna unselect these, and then I'm gonna select y3. The window, just based on the options, it looked like 0 to 10 would be sufficient. And then your y values, if you're just looking for when is the graph above or below the x-axis, then like small numbers around 0 would make sense, -1 to 1 or -2 to 2, something like that. So, so here's the function, and keep in mind this is the difference of the two derivatives. Whoops, what window do I have here? Hold on. 0 to 10. -2 to 2. Oh, okay, sorry, that's not an axis. Sorry, okay, so the graph goes, kind of does something down here and then comes back up. And so we're just looking for when is this above the x-axis, because you're just looking for when is it positive. So it looks like here's one place where the two graphs would have intersected, and then here's another one. And so, so basically I would go with -infinity to whatever number this is, and then whatever number this is to infinity. So now I'll just use the calculate and 0 feature to figure out what those numbers are. Okay, so this one is 0.831 something something, so I would go with, so this interval right here where f was higher would have been -infinity to 0.831-ish, and then this is in the other interval where e to the x was higher, and so that would be this part. And so you just use calculate, 0 again. Oh, that's funny. Oops, I didn't mean to do that. All Oh, I didn't like it. Oh, I'll do it again. Oh, was I in the wrong? I don't know what I was doing. Where's the cursor? I'm just jumping around. Oops. Oh, oh, it still doesn't like it. Oh, good night. Left bound, 7 point, sure. Right bound, yeah, sure. Guess, yes, please. Oh my goodness. My calculator's broken. One, 2, 3, 4, 5, 6. A little past 7. So it seems like a left bound of something like that should be totally fine. Oh, okay. Guys, I don't know where the cursor is. It's super weird. Anyway. All right, I just picked like, basically 7 and 8 would have been great. Okay, there we go. What is that? 7.3 something something, 384. There we go. All right, sorry about failing at technology there, but anyway, the correct answer ends up being B.